Solve the following system of equations algebraically. For this system, the coefficients and constants are all fractions. First, convert any mixed fractions to improper fractions. Then multiply each equation by a common denominator to remove the fractions. Finally, use either the elimination method or substitution method to solve the system. For this question, I'll use only the elimination method. For the first equation, the 2½ must be converted to 5/2, and for the second equation, 1½ becomes 3/2, and 3⅓ becomes 10/3. To find a common denominator for each of these equations, simply multiply all of the denominators. For the first equation then, multiply by 5, 3, and 2. The 5 cancels out the 5 in the denominator of 3/5a, resulting in 3 times 3 times 2, or 18a. Similarly, the 3 cancels out the 3 in the 2/3, giving 2 times 5 times 2, or 20b. Finally, the 2's cancel, giving 5 times 5 times 3, or 75. For the second equation, multiply everything by 7, 2, and 3. For the first term, the 7's cancel, resulting in 24a. For the second term, the 2's cancel, resulting in 63b. And for the third term, the 3's cancel, resulting in 140. For this system, I will be eliminating the variable a. To do this, I'll multiply the first equation by 4 and the second equation by 3. Note that 72 is the lowest common multiple of 18 and 24. This results in 72a plus 80b equals 300, and 72a plus 189b equals 420. We can then subtract these equations to eliminate the a, resulting in negative 109b equals negative 120. To isolate for b, we divide both sides by negative 109, resulting in b equals 120 over 109. We can then look at either of the equations we start with. In this case, I'll use 18a plus 20b equals 75, and substitute 120 over 109 in place of b. We then want to remove the fraction by multiplying the entire equation by 109, which is the denominator. 18a times 109 is 1962a. For the second term, the 109 cancels out, leaving 20 times 120, which is 2,400. And finally, 109 times 75 gives 8,175. To isolate for a, we first subtract 2,400 from both sides of the equation, leaving us with 1962a equals 5,775. We then divide both sides by 1962, which leaves a equals 5,775 over 1962, and then dividing both the numerator and denominator by 3, we get a result of 1925 over 654 for a. We then have our solution a comma b as 1925 over 654 comma 120 over 109.